This is exercise number 19 on page 245, and again I have a fractional equation here to solve, and I only have numbers and constants in the denominator, no variables, so I'm not going to have any domain restrictions or anything. So the thing to do is to rewrite this all in the lowest common denominator, and the lowest common denominator of 4, 10, and 5, pretty easy, to realize that that's 20. So if I want to rewrite each of these fractions, each of these rational expressions over 20, this one, to get this denominator to be 20, I need to multiply the denominator by 5 and the numerator by 5. So I just multiplied this by 1 in the form of 5 over 5. This one has to be multiplied by 1 in the form of 2 over 2 to be over 20. And this one, I need to multiply that denominator by 4 and the numerator by 4. So I just multiplied each of these fractions by 1 in different forms, and it doesn't change the value of any fractions, only their appearance. So now, to clear all those fractions in one fell swoop, if I multiply every term on both sides, I wrap it and I distribute 20, and I multiply every term by 20, all of those denominators will clear, and I'll just be left with the numerator of 5y times 2y minus 1 plus 6 equals 4y times y plus 2. So simplifying this, okay, so you can see that this is a quadratic equation and y as the variable. So I'm going to get everything on one side set equal to 0. So if I subtract 4y squared from both sides, I'll have a 6y squared. If I subtract 8y from both sides, I'll have a negative 13y plus 6 equals 0. So now I'm going to try and factor this to solve it. So I'll frame a couple binomial factors. And the trial and error process, I can put a 6y and a 1y here, or a 2y and a 3y. And then the factors of 6, I can put a 1 and a 6, or a 2 and a 3. So you can try around at this for a while, but I end up with a 2y and a 3y. And then if I put the 2 here to make a 4y with the outside product, and a 3 here to make a 9y with the inside product, I can use this 4y and 9y and combine them, they're both negative, to be a negative 13y. And then my product will be a positive 6 when I multiply. So FOIL that back to check it, and you'll see that those factors work. So the value of y that makes this factor here 0, therefore the whole equation true, has a 2 in the denominator and a 3 in the numerator, so it's 3 halves. And this one will have a 3 in the denominator and a positive 2 in the numerator, or 2/3. So the two solutions to this equation are that y is equal to 3 halves, or y is equal to 2/3. And I will leave the check for you to plug those back into the original equation and check them. But that's it.